Welcome back to part 2 of Module 201B. We're now going to talk about generator output frequency. In our last video, we talked a little bit about what an alternation is, and that's when we pass by one single pole in our generation cycle. And we also talked a little bit about what a cycle is, and cycle being two alternations put back to back. So that means I have to pass by two magnetic poles in order to create one cycle. When we talk about generator output frequency, we're talking about how many of those cycles can we complete in a given time frame, this time frame being 1 second. Frequency is represented by the lowercase f, and it's measured in the term hertz. So anytime we talk about 60 hertz or 40 hertz or 50 hertz, we're talking about the frequency of our electrical system, specifically the frequency of our generation system. When we talk about frequency and poles, one thing we need to know is how many poles are inside the generator. In a simple generator like we saw in the first video that only had two poles, one north and one south, that is considered to be a two-pole generator. If we have multiple poles, such as one you see on the screen, this is a four-pole generator. The more poles that we have means the more cycles that we can complete in the same amount of mechanical rotation. If I had a two-pole generator with just one single north, one single south, 360 mechanical degrees would complete two alternations or one cycle. And one cycle is equal to 360 electrical degrees. Now, if you look at the generator that we have on the screen, this is a four-pole generator. So since I'm going to pass by a north and a south, I actually complete passing by two different poles within 180 degrees of mechanical rotation. That means I've completed 360 electrical degrees, but I've done it in 180 mechanical degrees. The electrical degrees are all about how many times I can pass one pair of poles. The more poles, the more electrical degrees I can have per mechanical degree. So a four-pole generator is going to produce 2 cycles per rotation. So 360 degrees of rotation produces 720 electrical degrees. And this is great. This means that I can produce more electricity with using more poles inside the same generator. When I increase it to an 8-pole generator, that means I have 4 sets of poles. That also means that every 90 degrees mechanical rotation is completing 360 electrical degrees. So you can see how adding more poles really compounds how much electricity is being generated. In an 8-pole generator, we have 1440 electrical degrees, which is the same thing as 360 times 4, by the way. When we look at a generator, we can calculate how many electrical degrees can pass in one single rotation. Since for every single pole would count as 180 electrical degrees, if I multiply 180 by the number of poles inside the generator, I will come up with how many electrical degrees I would have per rotation. And then if I multiply that by how many rotations, I can get a total number of electrical degrees being passed. Knowing how to calculate our electrical rotation is one thing, but the other thing we need to know is knowing how fast our mechanical rotation is going to be as well. When we're discussing frequency, it is cycles per second, so I need to know how many electrical cycles are completed, and I need to know how fast they're completed. Speed plays a big factor. Speed is directly proportional to the amount of frequency. If I were to double my speed, I would also double my frequency because I can pass twice as many poles in the same amount of time. Also, if I doubled the amount of poles and I doubled the amount of rotational speed, I could also quadruple my total output. Here is our formula for frequency. If we take the number of poles inside a generator, multiply it by its mechanical rotational speed, and then divide that by the constant number of 120, we should come up with a frequency that our system is going to operate at. For example, if I had an 8-pole generator rotating at 1200 RPM, I would have a frequency of 8 times 1200 divided by 120, which would be 80 hertz. If I wanted to change the frequency, I could change the speed or remove poles. Changing the speed of the generator is generally easier than removing poles. If we look at this chart, we can see that both the number of poles and the rotational speed are directly proportional to the frequency. On the first generator, I have 4 poles rotating at 1800 RPM, which gives us a 60 Hertz, which is the same frequency we have in US and Canada and in Mexico. If I double my rotational speed, means I'm cutting twice as many lines of force, I'll also increase my frequency. So even though I still only have 4 poles, by doubling my speed, I've doubled my frequency. Alternatively, if I took an 8-pole generator at 1800 RPM, I would also double what that 4-pole generator had. So an 8-pole generator operating at the lower speed of 1800 RPM still produces the 1200 Hertz. And if I were to double the number of poles as well as double the rotational speed, I'd once again see a double over the other 8 poles. And an 8-pole generator operating at 3600 RPM would produce 240 Hertz of generated electricity. This brings us to the end of part 2. Go back to Blackboard, work on the worksheet as well as the knowledge check, and then you can continue on to part 3.